class, everyone. In this lesson, we will learn about the operation and maintenance of current transformers. This lesson requires understanding the function and working principle of current transformers, as well as knowledge of current transformer operation and maintenance, to thereby develop the ability to monitor current transformer operation, analyze faults, and handle faults. At the same time, cultivate awareness of electrical safety, develop analytical skills, and foster good professional ethics. The key teaching points and difficulties of this lesson are the operation and maintenance of current transformers. If in practical situations, a current transformer develops a fault, how should we perform maintenance? This requires being very familiar with the basic principles and functions of current transformers. A current transformer is a special type of transformer. It is composed of windings and an iron core. The current transformer converts the large primary current through the transformation ratio into a measurable small current on the secondary side. Its current ratio is inversely proportional to the turns ratio of the coils. The secondary current after transformation is generally 5 amperes or 1 ampere. The current transformer's primary winding is connected in series in the circuit to be measured. The secondary winding is connected in series with the current coils of secondary measuring instruments and relays. As shown in the figure, enters the current transformer at I1 and exits at I2, then connects in series with the current coils of measuring instruments and relays. The Anagel symbol for a current transformer is TA. There are two ways to represent its electrical symbol. In the first type, a straight line represents the primary winding, a circle represents the secondary winding, and two diagonal lines represent the output of the secondary winding. In the second representation, a straight line represents the primary winding and an inductor symbol represents the secondary winding. Next, let's introduce the operating characteristics of current transformers. First, the primary winding is connected in series on the power supply side. The secondary winding is connected in series with the load. The load impedance on the secondary side is small. Changes in the secondary current have a negligible impact on the primary side. At the same time, the following 4 points should be noted when using current transformers. First, the secondary side of a current transformer must absolutely not be open-circuited during use. If open-circuited, it will generate a very high induced electromotive force, thus endangering personal safety or damaging the current transformer. Second, one end of the secondary side must be grounded. This is to prevent injury to instruments and operating personnel in case the transformer's insulation breaks down. Grounding one end of the current transformer's secondary side does not affect the normal operation of the equipment, while also ensuring the safety of personnel and equipment. Third, pay attention to polarity during wiring. The primary side is connected in series in the circuit. The secondary side is connected in series with relays or measuring instruments. The permissible errors of current transformers include ratio error and phase angle error. Factors influencing these are primary current, secondary load, and power factor. The accuracy classes of current transformers are divided into 5 classes: 0.2, 0.5, 1, 3, and 5. Among these, accuracy class 5 is used for general measurement, while accuracy class 0.2 is used for precision instrument measurement. There are many types of current transformers. Below, we will get to know them specifically according to different classification methods. They can be divided into indoor type and outdoor type. Indoor type is suitable for power systems with voltage levels of 20 kV and below. Outdoor type is suitable for power systems with voltage levels of 35 kV and above. By number of primary winding turns, they are divided into single turn and multi-turn types. Single turn type refers to a current transformer whose primary winding has only one turn. Multi-type refers to a current transformer whose primary winding has more than 2 turns. By different insulating medium, they can be divided into dry type, cast resin type, and oil immersed type. Dry type current transformers are impregnated with insulating compound and are used in low voltage indoor switch gear test. Resin current transformers are cast with epoxy resin and are suitable for switchgear from 3 to 35 kV oil. Immersed current transformers use transformer oil as the insulating medium. In voltage levels from 10 to 220 kV by installation method, they can be divided into supported type current transformers and bushing type current current transformers. Supported-type current transformers are generally used on planes and pillars. Bushing-type current transformers, also called sleeve-type current transformers, are set on the transformer tank's bushings to save on bushing insulators after understanding the basic knowledge of current transformers. How should they be installed? According to what wiring methods? Let's learn about this together. Below in the figure diagram shows single-phase wiring. It is used to measure single-phase load current, or the current in one phase of a balanced three-phase system. Diagram shows three-phase star Y wiring. It is used to measure the three currents in a three-phase power system, whether the load is balanced or unbalanced. Diagram shows two-phase VEEV connection wiring, also known as incomplete star wiring. It is widely used in 6 to 10 kV neutral point ungrounded systems. Let's learn about the precautions for current transformer operation and maintenance. Our routine inspection is required before putting a current transformer into operation. The main inspection items include the following 5. First, check if the porcelain insulator is clean, free from damage, cracks, and discharge phenomena. Check for normal sound. Second, check if the oil level in oil-immersed voltage transformers is normal, and check for any leakage. Third, check all connections for overheating and sparking. Check if bolts are loose, and check for any abnormal odors. Fourth, check that the secondary winding is not open-circuited. Check if the grounding wire is in good condition, and check for looseness or breakage. Fifth, check if the three-phase indications of the ammeter are within the allowable range. Here, the teacher needs to emphasize, everyone must develop good electrical safety awareness and good professional ethics. Complete the inspection of all items according to the inspection procedures. Students, we also need to pay attention to the following issues during operation. First, the current transformer secondary circuit may experience issues like terminal screws loosening by themselves due to vibration, causing an open circuit in the secondary circuit. The signs are spark discharge at the open point and a buzzing sound due to electromagnetic vibration. Second, if a metering current transformer opens, the phase ammeter will read 0 and the energy meter's speed will decrease for protection current transformers. 0 sequence, negative sequence, and differential protections may operate incorrectly. At this time, first inspect the load circuit supplied by the current transformer. Then take the differential, 0 sequence and negative sequence protections it supplies out of service. If a current transformer is operating with an external open circuit, the operator should wear insulating shoes and gloves. First, short circuit and ground its secondary side, then address the broken wire or loose connection. And finally, remove the grounding short circuit wire to restore normal operation. Fourth, if an internal open circuit occurs in the current transformer, it should be handled after de-energization. During the period the current transformer operates with an open circuit, the primary current should be appropriately reduced, and the protection team should be notified promptly for handling. Fifth, if excessive heating, high temperature, internal discharge sounds, or serious oil leakage are found, it needs to be de-energized immediately. 6. If smoke is found inside the current transformer, or if it catches fire, use a circuit breaker to isolate it, and extinguish the fire using a carbon dioxide or other suitable fire extinguisher. Students, in this lesson, we mainly learned about the function and working principle of current transit, transformer operation and maintenance, and other content. It is required that everyone, combining the above content, establishes a sense of rigor and conscientiousness, and during inspection checks, must be good at discovering problems that are prone to occur in transformers. Please use your spare time to think about the following questions. That is all the content for our lesson today. Thank you, everyone. Goodbye.